problem. Okay. So first you see a person wants to decide the constituents of a diet which will fulfill his daily requirements of proteins, fats and carbohydrates at the minimum cost. The choice is to be made from 4 different types of foods. The yields per unit of these foods are, so here types of foods are given and yield per unit also given. So food type 1, 2, 3, 4 given, and here proteins in this food there are this contains protein, then fats and carbohydrate. So here given also cost per unit given 40 for food type 1 rupees 45, then food type 2 is 40 in the table you see second page, then food type 3 35, then 65, and minimum requirement for protein is 800, 200 for fats and carbohydrates 700. So food type here, 4 types of foods, right? So first we consider what? Let x1, x2, x3, x4 denotes the number of units of food of type 1, 2, 3, 4 respectively. And then object is to be minimize the cost, right? Here objective function is what? Objective function is minimization, right? So next page you see I have given 1 unit of food type 1 cost is rupees what? 45. So here food type 1 rupees is given in the table. First row you see rupees is 45, right? So here rupees is 45, then x1 unit of food type of 1, food type 1 cost will be 45 into x1, so rupees 45 x1. Next one will be what? In food type 2 cost is rupees 40 and this is per unit. So here we consider x2 unit of food type 2 will be what? 40 into x2. Then per unit food type of 3 cost is 85. So x3 unit of food type of 3 cost will be 85 into x3. And then 1 unit food type of type 4 cost is rupees 65. So x4 unit of food type 4 cost will be 65 x4. Then total cost of food type will be what? Sum of this means total cost of food type will be, we consider this is the variable z. So z equal to 45x1, then 40x2 plus 85x3 plus 65x4, right? So next what is given? These are the restriction. In the table you see, in the table minimum requirement. So minimum requirement for the protein is 800, fats is 200 and carbohydrates are 700. So these are the constraint, means what? This is the restriction, you'll remember. So this one will be, next you write, minimum requirement of the proteins 800 units. So for here you see for food type, here proteins food type 1 3, food type 2 4, and food type 3 proteins 8, and food type 4 protein is 6, right? So here you see I have written 1 unit of food type 1 contains 3 unit of protein. So this one will be what? X1 unit of food type of 1 will be 3x1. Similarly, food type of 2 contains 4 unit of protein. So here x2 unit of food type of protein 4x2. Then 1 unit of food type 3 contains 8 unit of proteins. So x3 unit of food type of 3 contains x3 unit. Similarly, 1 unit food type 4 contains 6 unit of protein. So x4 unit of food type of 4 contains 6x4, right? So this is the proteins restriction. So proteins restriction will be total will be 3x1 plus 4x2 plus 8x3 plus 6x4. And this is the minimum requirement is 800. So some of these minimum will be 800 or more. So here this restriction will be what? Greater than or equal to. Question is what? Suppose if you join suppose any course, minimum requirement is 45%. So if minimum requirement is 45%, then what happen? 45% means what? Your mark should be percentage should be either 45 or greater than 45, not less than 45. So similarly here protein, here minimum will be 800. Some of these 4 proteins should be greater than or equal to here given 800. So this is for the protein. So similarly for fats, this one will be twice x1 plus twice x2 plus 7x3 plus 5x4 greater than or equal to 200. And for carbohydrate also 6x1 plus 4x2 plus 7x3 plus 4x4 greater than or equal to 700. And x1, x2, x3, x4 greater than or equal to 0. So this is the formulation of this linear programming problem. So you see, and here x1, x2, this is what? x1 and x2 denote the number of units of food type 1, 2, 3, 4. So this should be greater than or equal to. And here objective function will be minimize. Okay. So this is will be formulate the linear programming model. So this one will be, this is the formulation of the linear programming model. So this one is clear. A dietitian mixes together 2 kinds of food, say X and Y, in such a way that the mixture contains at least 6 units of vitamin A and 7 units of vitamin B and 12 units of vitamin B and 12 units of vitamin D. Contents of 1 kg of food X and 1 kg of food Y are given. Cost given food X and food Y, and vitamin A, vitamin B and vitamin C and vitamin D are given. Those are given. 1 kg of food X cost is rupees 5, whereas 1 kg of Y cost rupees 8. Formulate the linear. So you will try to solve this. Optimal solution. Suppose in a graphical method, given one linear programming problem is given, what do we mean by optimal solution? Anyone? Full region. Suppose one graphical method is given. You have draw the graph. Okay. After drawing the graph, then what is feasible region? Anyone? Means what? Any point in the feasible region that gives what? Either maximum value or minimum value. This is called the optimal. Means what? Suppose one linear programming problem is given, right? So this gives us what? Either maximization or minimization. means maximum profit or minimum cost. This is called what? Optimal solution. So any point in the feasible region. So feasible region is what? Feasible region is what? Feasible region means, suppose constraints are given. Yes, my book. The feasible region means what? Given. So in this feasible region, this point, all these constraint, this satisfies. Means what? Suppose when you draw the graph, then you will see common region. This is called the feasible region. Means in the feasible region, some points are in the feasible region. Okay, if you take the points from the feasible region, then these points satisfies all the constraints in the graph. Then this is called the feasible region. Because in constant what? In constant, this is either less than or equal to, greater than or equal to symbol present, and this satisfy. Because you see, suppose y greater than x, greater than or equal to x, then this is the equation of a straight line. Means this is y equal to mx format, right? So y greater than or equal to x, right? Then region will be what? This is equation of the straight line passing through origin. Equation of the straight line passing through origin. When this is equation of the straight line passing through origin, then what happened? Then region will be which one? See, which axis means which variable is greater? Y variable is greater than x. Then if y variable is greater than x, then what happens? Y variable is greater than x, then region will be in y axis, right? You will shaded the region in y axis. If x is greater than y, then your region will be in x axis. So you will remember in this way. Formulation of the linear programming problem and graphical method and short type question. I shall take one exam on